Today we're going to learn about soda. So what I'm going to do today is to show that when you shake a soda, the pressure does not actually increase in the bottle. I'm also going to teach a little bit about
maybe salt is not only a pure flavor, but it just enhances the hydration, so the osmosis, I think it's called.
equilibrium and why the pressure doesn't actually increase when you shake it. In addition, I'm going to show if the pressure does increase, then why does your soda still explode when you open it? So in order to test this, I'm going to finagle up a measuring system where I can measure the pressure inside of the soda. So here I have an inner tube, and I'm going to cut this out and put it inside of the lid and tighten the lid back down. Okay, I'll cut the inner tube out and put it inside the lid here. Let's see if it holds the pressure now. So this experiment will work best with a non-frothy drink like Sprite. So I'm going to use Sprite first. So first I need to put my pressure measuring lid on, this way. Now since I opened it and released the pressure, I'm going to give it a good shake again. This will release some of the CO2 from the liquid into the headspace up here and repressurize it. I'm going to let it sit there for a few minutes. Okay, it's now at equilibrium. I've had to wait all night to measure the pressure and see what it is. Okay, about 30.5 psi. I'll shake it up. Yep. 30.5 psi. Shake it one more. See how the bubbles. 30 psi. Equilibrium in terms of our soda bottle experiment just means that there's the same amount of CO2 in the gas dissolving into the liquid as there is CO2 in the liquid going into the gas. This means that there's no net change in CO2 in either the liquid or the gas, so the pressure does not increase. If that's the case, why does your soda explode when you shake it really hard and then open it? When you shake a soda bottle, a lot of small bubbles form. Most of them are microscopic and you can't even see them. It's worse in a frothy drink like soda or Coke. These bubbles stay small under the pressure of the soda bottle. However, when you release the pressure, those small bubbles suddenly become large bubbles as the volume expands due to a decreased pressure in the headspace. The large bubbles expand, pushing the liquid out the top. If it's a very frothy drink, then it pushes a lot of liquid out, and it ends up spraying all over the place. If you're going to try an experiment similar to this, or try shaking your soda up, here's something you need to remember. Remember that the pressure will not increase only if the system is at equilibrium. So if you're just opening your soda hot, and then you put the lid back on and shake it, the pressure will increase because the shaking just helps the system get to equilibrium faster. However, once it's at equilibrium, it will not increase the pressure of shaking. This video is in 593, and so doing it, I need to
Freunde der Sonne, was ihr über Sonnencreme wisst, ist falsch und ich bin Mitschüler. Ich weiß, steile These, ich kann ja nicht wissen, was ihr alle über Sonnencreme wisst, aber ich kann zumindest für mich sprechen. Ich habe sogar ein altes Video von mir gelöscht, denn das, was ich glaubte, über Sonnencreme zu wissen, ist falsch und ich fürchte, ich bin nicht die Einzige. Deshalb jetzt Zeit für dieses Video. Wir mögen die Sonne, aber zu viel in der Sonne liegen ist nicht gut, das haben viele schon schmerzhaft erfahren, aber selbst...
So I already wrote
When we look at our best understanding,
this comment that actually you can just use different biological things. Such as not really made from trees. But a mixture with probably sugar, a little bit, and then also not oil or something, because oil is getting maybe into the skin. You can even use coconut stuff and very thin layers, almost like peppermint, and then it's not bad for the environment or something, because most artificially made things are not so natural and compressed and stay like that for a too long period of time. And yeah, So actually, almost everywhere, this problem of microplastics, plastics, in almost everything can be replaced with, just those things made more biologically.
Of the fundamental laws of physics. Time does not have direction. But in the world, in the real world that we know about, there's clearly an arrow of time. Why is there this imbalance of past and future in our experience, even if it's not the laws of physics? It can be summarized by saying that the early universe is a very low entropy configuration. We can say with confidence there's an arrow of time because entropy is increasing. Entropy is increasing because it started out very low. Then we give out. Like, why did it start out very low? Nobody knows. But we also don't know what happened at the Big Bang. There's a very old idea, the idea that the universe has cycles. You can easily say that I can imagine a universe that expands, stops expanding, and recontracts. But at the beginning and the end, the Big Bang and the Big Crunch, your equations break down. You have singularity, you don't know what's. So there's a long tradition in cosmology of trying to work around that problem. Of saying, well, I have exotic forms of matter, or I have quantum mechanics, or whatever. So maybe I can replace the singularity of the Big Bang with a bounce of some sort. One big question with these models is the arrow of time. Almost all of the existing models of cyclic cosmologies have an arrow of time that points uniformly from the infinite past to the infinite future. Our new trick is to say, what if we take quantum mechanics seriously? Don't start with the classical theory. Start to quantize it, just use the Schrodinger equation. Just do quantum mechanics from the start. When it heads toward that crunch, in this model, it's just like the time reverse of the Big Bang. It really is an exactly periodic solution. So entropy decreases toward the crunch, and then you bounce and you have another Big Bang, and it's an exact copy of this cycle of the history of the universe. We will always, by we I mean anyone in the universe, will define the past to be the direction of time in which entropy is low. So on the side of the cycle we call the crunch in our future, they, the people who live there, will say that we are in the future, because they will define time oppositely, because they will define time with the past being toward the crunch. Okay? So that's one reversal of the arrow of time. The other one, in what we call the future, the universe is going to empty out. But what's going to happen is the heat death of the universe. Rather than zero entropy, the universe will have maximum entropy. It will be in thermal equilibrium. So it's not that the arrow of time suddenly reverses, so it gradually ceases to exist. The stars will burn out.
Essential water, it stays like pH 9.5. And indeed, when I add universal indicator to essential water, I do indeed see a color shift to violet. That makes sense to me. I've also heard the claim that this stuff alkalizes your body. The same amount of protons that I'm going to deliver here to our essential water plants will look perfect in your body. I don't know, let's give it a shake. Take that one, Pop Roll.
Behind me, each of these bales weighs about 1,000 pounds and contains about 30,000 aluminum drinking cans. Here in the United States, Americans consume about 100 billion cans a year, and they need to be recycled somewhere.
The big bales of cans are offloaded from semi-trucks and stacked neatly, positioned in rows ready for their turn to be grabbed by the claw. The claw is really a gravel excavator that shreds full bales of cans to get them ready for processing. Thumbs up for that cool machine. Once the bales are broken open, the big front loader can then scoop up the loose cans and drop them onto a vibratory conveyor belt. The vibrations help sift the cans down onto the conveyor uniformly, so the facility inside has a steady stream of aluminum scrap to work with. Shredding makes sure that there's no liquid remaining in any of the cans, since liquid could be catastrophic to the furnaces, as we'll talk about later. This delacquering process strips away the paint and enamel on the outside of the cans to get the aluminum cleaner before it falls into the furnace. And curiously, the best way to mix the new can scraps in with the already hot molten metal is with two mechanically stomping feet, like some kind of steampunk wine press. The oversized aluminum boot stompers help press the top layers of scrap down into the molten aluminum underneath. Aluminum melts at about 1,240 degrees Fahrenheit, so these furnaces are cooking, quite literally. I had to put on some special PPE to keep me safe. This aluminumized jacket and gloves do two things. They reflect a lot of radiant heat coming from inside the furnace, while at the same time they're made with aluminum themselves, so if there is any accidental splashes, the aluminum would beat up and roll off of my suit, keeping me safe underneath, hopefully. Speaking of splashes, one of the biggest concerns here at the factory is liquid getting inside of the furnace, or the crucible. Since liquid water expands about 1,000 times in volume when it turns to steam, any cans with liquid still inside of them would create an explosive silver lava bubble, which is why the shredding and drying process is so important. Now that we have the molten aluminum lava all melted up inside the furnace, it's time to collect it all in the largest crucible I've ever seen.
Warum kann ich das so machen? Ich denke, das weiß jeder, der was benutzt. Das ist gehasst.
Das ist so bei vielen anderen Filmen auch.
This is today called the Born Rule. This is what he wrote down as a casual.
For 60 years, every attempt to replace silicon has failed. Virtually, carbon nanotubes, and dozens of plasma materials that were supposed to be the future. None of them made it. But now, for the first time, the semiconductor industry may have finally picked a successor. A few weeks ago, I was there when IBM presented the new chip roadmap, and on it something remarkable happens. Silicon starts disappearing, not from the computer, but from the roadmap itself. And the material taking its place is just a few atoms thick. I'm a chip design engineer, and in this episode we will explore a new material that could replace silicon. The first microchip already running it, and what it tells us about the future of computing. Subscribe to the channel and let me explain. For more than 60 years, the entire computing industry has been built on a single material, silicon. Every smartphone, every laptop, every AI chip, and yet silicon was never supposed to make it this far. For decades, the semiconductor industry was obsessed with making transistors smaller, and every new generation unlocked cheaper and more powerful computing. But eventually, we ran into something we couldn't shrink away. Physics. As transistors approach atomic dimensions, strange quantum effects start to appear, like quantum tunneling. When electrons behave like waves, which means they can pass through barriers they were never supposed to cross, they actually started leaking into places they were never meant to be. And at the same time, every new generation became far more expensive and far more difficult to manufacture. It looked like the dead end. Yet every time engineers found another trick. First, transistors stopped being flat and became FinFETs. Then we figured that we can wrap the gate all the way around the channel, giving us gate-all-around architecture. And honestly, the result is breathtaking. You only add Intel's first 18A transistor. Those tiny horizontal bars are called nanosheets, and they're the pathways where electrons flow. These are only a few dozens nanometers wide. And they're engineered to switch faster while leaking less current. And it's getting even crazier if you look underneath. Those darker lines are so-called power via. Instead of delivering power through the crowded top of the chip, Intel routes it from the backside. And this is two of the hardest problems in modern chip making solved in the same device. You would think that there isn't much room left for new ideas, but the industry wasn't done. Now we are building CFETs, an attempt to build two transistors in the space of one, literally stacking one transistor on top of another. And after that comes even more stacking. If you've seen my episode on China's new scaling law and chip folding, you will know exactly where this story is heading. Every generation bought silicon a little bit more time, but eventually every trick runs out. And a couple of weeks ago, I was there when IMA presented it. A new chip roadmap all the way beyond 2040. This is a roadmap. The next decade looks familiar. 2 nanometer class chips today, then the industry moves towards A7, 7 angstrom class technology around 2023, which will be a remarkable milestone, the first commercial introduction of CFET. But then something strange happens. Around 2041, silicon starts disappearing. Not from the laptop, but from the transistor.
Also, here's a universal material approaching here. Should be actually the go-to solution to that. Even though the coding is different than probably. Has to be better.
Tina, du hast so eine tolle Ausbildung. Kannst du damit nicht Ordentliches machen? Vielleicht sogar was mit Mehrwert? Hello, ich bin Tina, ich mache Comedy, meistens im Internet, aber ursprünglich war ich mal Sozialwissenschaftlerin und wie das aussah und warum ich das jetzt nicht mehr an der Uni mache, das erzähle ich euch in diesem Video. Dieses Video ist für dich, falls du über eine Karriere in der Wissenschaft nachdenkst, und es ist auch für dich, falls du jetzt von meinem wissenschaftlichen Hintergrund erfahren hast und demzufolge wie jeder andere mir bekannte Mensch denkst. Du hast einen Doktortitel. Ich habe promoviert, ja. Du warst also mal beruflich schlau. Naja, also ich habe politische Einstellungen untersucht, vor allem zu den Themen Umverteilung und spannend, ja. Du bist also Frau Doktor. Ja, aber jetzt erzählst du Witze im Internet. Ja. Sag mal, hackt's bei dir? Natürlich hackt's.
Im Jahre 2026, nach einer weiteren vernichtenden Niederlage bei der Weltmeisterschaft, zog Deutschland die letzte Konsequenz. Menschliche Spieler waren zu schwach, zu eitel, zu verletzlich. Also setzte man auf das, was Deutschland einst groß machte. Ingenieurskunst. Keine Mannschaft, keine Ausreden, keine Gnade. Nur eine einzige Maschine, die schießt, verteidigt, trainiert und alles vernichtet, was sich ihr in den Weg stellt.
Willkommen auf meinem Kanal, willkommen zu Free Energy. Ich begrüße.
So actually in iFuJaren, they are playing already enhanced soccers, or it's a mixture of different sports.
Ich euch vor allem meine kleinen Energieprojekte. In diesem Video stelle ich das Projekt Fernwärme vor. Am Ende der Videoreihe wissen wir, ob es funktioniert und wenn ja, wie man ihn bauen sollte, um das gewünschte Ergebnis erreichen zu können. In der heutigen Zeit werden viele Videos produziert, die zeigen sollen, wie einfach es geht, Energiekraftwerke zu bauen. Unzählige Interessierte bauen dies in stundenlanger Bauzeit nach, nur um am Ende festzustellen, dass gar nichts passiert. Diesen Umstand möchte ich mit meinen Videos für kleine Energie beenden. Mit geeigneten Messmethoden soll festgestellt werden, ob ein Konzept funktionieren kann oder nicht. Ich suche mit Wege aus, die vielversprechend sind, und stelle entsprechende Produktreihen auf. Sollte sich herausstellen, dass Energie erzeugt werden kann, können Interessierte anhand der Resultate eigene Modelle oder ausgewachsene Energiekonverter bauen, ohne enttäuscht zu werden. Als Einstieg zeige ich euch nun das Originalvideo des Fernwärmemotoren in Englisch. Viel Spaß!
You'll notice that the rotor and stators are constructed of a plastic called Tufenol. The frame is of tubular aluminium.
main bearings in the unit are high-speed self-centering bearings. This particular motor develops some 9 kilowatts of power. This unit is with the manual speed control, which you can be seen now. The later versions have electronic speed control. Going in now towards the rotor, you'll notice the magnets and the plastic stay pins. These are to keep the magnets in place. In front of the magnet, you'll notice a half-moon cutout. That is for the new shielding to go in, which we're currently waiting for. There are 3 main rotors, and they all offset at 20-degree angle to each other. This will allow the motor to run. This is the motor now starting up. You'll notice that the stakes are going in toward the center rotor.
All eyes look to me now. That's justified. My father's faith in me.
Du beginnst deine App auf der Base 44 zu erstellen. Du beschreibst sie und sie wird real. Einige Sachen.
Today we're testing the world's wildest discontinued food gadgets. From brilliant inventions lost to history, to wacky steak searing devices that I can't believe actually existed, to culinary prototypes that are straight up dangerous. But today I'm on one final mission. Which of these antique gadgets are worth bringing back, and which should be left in the past?
All right, Max. Item number 1 is a vintage steak broiler from the 1940s.
I'm gonna be honest. Speaking, that color looks great. There's only one thing that truly matters. I mean, that is near perfection. I mean, it's tender, juicy, really nice char flavor. That is everything I want to see.
The 1940s electric steak broiler. Are you going to revive or retire it?
I mean, I can't stop eating the steak. This guy right here, it's no question, we're gonna revive it.
You know that wasn't clean, right? There's 1940s dirt in there. All right, next up, we got the Presto Deluxe Hot Dogger.
This is converting right here. We got a wiener dog as our logo for the hot dogger. Cooks 1 to 6 hot dogs from the inside out in just 60 seconds. Just looks retro. It also looks like some sort of torture device. Like you put your hand in here and it just demolishes you. You actually have some directions here. Okay, we need those. Why the discontinue?
I mean, it electrocutes a hot dog.
That's sick. In the USA too. It's cool. See, I don't know how to open it though. See the shirt. See? Oh, okay, here we go. See, the hot dogs run this way, and they literally, there's electric volts that I believe send electric charges through the dogs. That is intense. All right, tell me a hot dog. Who invented this machine? That'd be sick, man. We're sending electric currents through the wieners. And they said it'd be in 60 seconds. This is bananas. All 6 dogs are in. Now we'll shut the hot dogger. As prongs fully attached, we'll plug it in.
Hello everyone, this is your Davis of Science. This professor made an iodine clock reaction that cycles between 3 colors.
This one oscillates the cycles between the 3 different phases.
So they wanted to show how fast the robot they made can get back up.
Okay, go. Oh, is that awesome?
This is my office. Schon ab 2030 werden wir wohl weltweit mehr Energie brauchen.
Yeah, so a lot of times in history, especially with buildings, it's better to make bio things, not for war, but for everything else, actually, for a functioning body like Fujera future system.
Pre-cartel light bulbs. There's something you don't know about light bulbs. They have a darker story than you imagine. By the early 1900s, some bulbs were lasting 2,500 hours or more, and the technology kept improving. There was one bulb installed in a fire station in 1901, which is still burning today, over 120 years later. So what happened? Why did bulbs stop getting better and actually start getting worse? In 1924, a group of the world's biggest light bulb companies got together and formed an agreement. This agreement became known as the Phoebus Cartel, named after the meeting point they used in Geneva. What they agreed on was insane. They decided that light bulbs should not last more than 1,000 hours. If any company made a bulb that lasted longer, they would be fine. The idea presented to the public was that a shorter burning bulb actually produced better light, and there was a small truth in that. Brighter filaments do tend to burn out faster. However, the 1,000-hour limit was not chosen because of light quality. Long-lasting light bulbs don't need replacements, which of course leads to fewer sales. The cartel lasted until around 1939, when World War II disrupted global trade and the agreement fell apart. But the 1,000-hour norm had already settled into the industry as a kind of standard. Even after the cartel ended, that number stuck around for decades. America's electric streetcars. Many Americans today complain about the lack of public transport. However, there was once a time where they had one of the best rail systems in the world. In the early 1900s, American cities were full of electric streetcars. They were used by millions of people every single day. And for example, Los Angeles alone had over Aereo. Around 2012, a technology startup called Aereo launched in New York City with a service that seemed too good to be true. Aereo had constructed facilities filled with thousands of tiny individual antennas, each one about the size of a dime. When a subscriber signed up for the service, they were assigned one of these antennas. That antenna would pick up over the air broadcast television signals and stream them over the internet to the subscriber's device in real time. For around just $8 a month, you could watch live broadcast television on your phone, tablet, or computer without needing to have a much more expensive cable subscription. Since any individual could have put up an antenna and watched them, Aereo are for Loco.
I did a search for ways to make extra income as a software engineer, and data annotation came up.
After doing this. In the late 2000s, 3 college guys noticed how popular and expensive it was to mix Red Bull and vodka at bars. This happened because people were trying to consume large amounts of alcohol without experiencing the natural tiredness effects of the liquor. They started a company called Fusion Projects and created a new drink called Four Loko. It cost about $2 and it contained caffeine, alcohol, and a few other stimulants mixed together. It spread wildly among 1992 Hoover free flights. In 1992, the British division of the vacuum cleaner company Hoover ran a promotional offer that has since become one of the most studied marketing disasters in business history. The deal was simple. Buy a Hoover appliance worth at least 100 pounds, and you would receive 2 free return flights to Europe or the United States. At first glance, this looked like a standard promotional deal, but anyone who looked at the numbers carefully could see the problem immediately. Flights to the United States from the U.
Three things Korea does better during summer. First, during hot summer days, Korea installs misting systems in public areas like bus stops. They spray a fine mist into the air, cooling people down while they wait. It's like standing in front of a giant outdoor fan, but better. Next, staying hydrated is taken seriously. Free drinking water can be found in many public places, making it easy for people to cool down during the summer. Even trees are taken care of, with water bags attached near their roots to keep them hydrated in the heat. And lastly, Korea uses road sprinklers that spray water onto the streets. This helps reduce dust and lowers the temperature of the road during summer, making the environment a bit more comfortable for everyone.
Oh, well done. Guys, sorry, please.
Yeah, but that's fun, at least. He was stuck. Yeah, fun.
That Bill backed his Nippon progeny financially and philosophically in her Shakespearean and magnitude power struggle with the other.
Grains aren't supposed to stack straight up. They always collapse into a slope, limited by something called the angle of repose. But what if that rule could be broken? In this video, we're going to talk about the angle of repose, and how shifting its parameter can create an almost magical property, like vertical stacking and even self-sorting. Now, before we continue, I want to thank Dreamy for sponsoring this video. This is the Dreamy FP10, and it's basically like a robot vacuum for the air. Normally, if you have pets, you see fur floating through the beam of sunlight and dust is dripping around the room, and it ends up everywhere. But the cool thing about this purifier is that it uses what Dreamy calls loop-boosted airflow, which means it actively pulls floating air and particles toward the machine instead of just passively waiting for them to wander in. So it's not just bringing air right around the purifier, it's actually helping grab the stuff that's still moving around the room. Most air purifiers just trap all that junk in the filter, so over time the filter gets clogged. But the Dreamy FP10 has an active fur collection and self-cleaning system that gathers the hair into a separate visible chamber. So instead of everything just matting into the main filter, a lot of that pet hair gets collected where you can actually see it, empty it, and rinse it out. That means less maintenance and your main filter stays cleaner for longer. It also has a 4-stage filtration system with an H14 HEPA filter, so it's not just for fur. It's also capturing really tiny particles, allergens, dust, and helping with odors too. I did a quick test with my air quality monitor and some fog spray, and immediately the air quality dropped to 0. But very quickly after I turned on my Dreamy filter, all of the particulates were filtered out of the air. So if you've got pet smells or just that stale air that builds up indoors, this is built to help with that as well. So if you want to check out the Dreamy FP10, I'll put the link in the description and the pinned comment. So big thanks to Dreamy for spot back to our experiment. In 2013, the largest landslide in U.S. history occurred when 100 million tons of rock came crashing down at Bingham Canyon Mine in Utah. Luckily, no one was injured because engineers knew it was going to happen. The reason they knew was because of a property of all grains called the angle of repose. It's not hard to figure out the angle of repose for a certain grain. You just pour it into a pile and it naturally forms a maximum slope. That slope depends on properties like shape, friction coefficient, and cohesion between particles. Chia seeds have a very low angle of repose, around 16 degrees. The highest angle of repose of normal materials is around 45 degrees, like this flower here. Once that angle has naturally formed, if you cause it to be steeper, then it'll cause an avalanche that adjusts to the right angle again. That's why avalanches occur in snow-covered mountains, and why engineers carefully design slopes in mines, road cuts, and construction sites to remain below this critical angle. What's weird is that when you mix two grains with different angles of repose, they don't form an average slope though. Instead, they do something unexpected. For example, in this box I have one type of sand with a low angle of repose, and one with a higher angle. So let's shake them and try to mix it together. But now watch what happens when we pour the sand. You can see that it forms these striations or stripes. These stripes happen because each type of grain flows differently as a pile forms. The grains with the lower angle of repose move more easily, so when an avalanche happens, they travel farther. The grains with the higher angle of repose are more resistant to motion, so they stop sooner and pile up higher. So instead of mixing evenly, each tiny avalanche acts like a sorting process, separating the grains based on how easily they move. You can kind of see this process happen, where instead of piling up, we watch it.
Es ist an der Zeit, sich von alten Gewohnheiten zu verabschieden. Mit der intuitiven Arbeitsmanagement-Plattform von Monday.
Slide down. You can see that they kind of take turns here. The white and then the blue, and then the white and then the blue. Over time, this repeated process builds visible layers. So just by having different angles of repose, the system naturally organizes into in a bag and moving around. These layers always form. It's so weird that differences in angle of repose keep the materials separated, but it seems like they should just mix together. That's how these desktop sand toys work. Even in water, the different angles of repose create striations, and the sands never fully mix. They're really cool to have around. You turn it upside down, and it forms a new structure every time. Are the porous material ends, so the sand is already stacked up a few centimeters above that point. So you have this porous media that can suck up the water around it while keeping the sand stable and letting the other sand that doesn't stick flow over the edge. Now when you pour the sand on, the water can wick up and the other sand around it doesn't build up and it starts stacking higher.
Yeah, the good thing about those nice science gadgets is that it's almost always very useful. It can be implemented extremely useful for most of the time.
I think this is too often in physics. People who think a certain area is very beautiful mathematics, and therefore it's got to be true of the physical world. And there is a big branch, perhaps I shouldn't be rude enough to mention what this main branch is in that area, but there is string theory. I do mean string theory. Okay. No, there's a lot of feeling that this must be the basis of physics because it's such beautiful mathematics. And I say that's not a good guide at all. Just because you think mathematics is beautiful in certain respects, sure. But that's not a good guide in itself. Thank you very much. And so it's a huge honour to be here talking to Roger. I thought I'd begin by saying that when I was an undergraduate, so I started doing physics at Manchester in 1992, I think it was. And one of the first books I read to prepare me for my undergraduate physics was The Emperor's New Mind. And I think we might talk about consciousness later on, but the two things that really stuck with me was that book gave me my default picture of quantum mechanics, which I always carried with me. But also, it for the first time, I think made me think about mathematical beauty. And I remember so vividly reading about how you describe complex numbers and the fact that mathematics is beautiful. So could you talk a bit about that idea that mathematics is a beautiful thing, and also mathematicians have a sort of an aesthetic?
Yeah, so, I mean, if you think about it, if there would be nothing, and I also wrote it already multiple times, I mean, I don't know if it really makes sense in a way that there is nothing before, because some people may refer to the universe as basically everything. So even if there was a Big Bang, some people would call the thing before the Big Bang still part of the universe in a way or whatever, because there is no bigger word we have, so most of the time, as far as I know, I'm concerned about other people especially, so I'm addressing that a little bit. Therefore it's more likely with things or with existence overall that over time infinites or infinites of infinity of nothing would add up to something in a way, because of space, whatever, that would be a theoretical thing, but yeah, so this is just in general how things could make sense up to our understanding and thinking and logic. So yeah, I mean, again, like ants or anything, there are obviously higher dimensional probabilities or possibilities, especially that just are not really that easy for us to understand. Maybe we can see it with analogous similarities we understand, but yeah, just like with the ants and stuff. But
Hi, ich bin Simon Anna und habe mich echt auf mein erstes richtiges Gehalt gefreut. Ich war nicht darauf vorbereitet, wie viel da noch von ab...
And here come the
so after this video, I think should be enough for this episode.
On the morning of the 17th of April 2013, the journal Annals of Mathematics received a curious email. It claimed to contain a 50-page proof relating to one of the oldest unsolved problems in mathematics, a problem that great mathematician Edmund Landau called unattackable. But this proof didn't come from a famous professor, it came from an unknown. Someone who had once spent years working at a Subway restaurant. So they're like, okay, surely this isn't going to work out, but whatever, we'll send it to a referee. They expected to find a mistake in an afternoon, but they didn't. So they went through it again, closely studying the fragile parts where a proof like this normally falls apart. But still, nothing. Soon, they realized they were witnessing a breakthrough. Hot damn, he did it. So how did he do it? What did the experts miss, and what was the problem he was working on? He was working on a new way to attack one of the hardest unsolved problems in number theory, the twin prime conjecture. The twin primes are prime numbers separated by just one number, like 11 and 13, or 17 and 19. As you go up the number line, primes become rarer, and twin primes become rarer still. But the twin prime conjecture claims that there are infinitely many of them. You never run out. But is it true? Well, one way to approach this problem is to look at gaps between consecutive primes as you go up the number line. Now, at first, they seem chaotic, but if you average them out, a clear trend emerges. The average gap between two primes grows roughly as the natural logarithm of the number n. So, for example, the average gap between primes around 100 is approximately 4.6. The average gap between primes around 1,000 is 6.9. Logarithms grow very slowly, but they do keep growing forever. So, as n approaches infinity, the average gap between primes also goes to infinity, which is not particularly encouraging if you expect to always be able to find primes that are just 2 apart. But if you start checking large numbers, then after a million, you quickly find the twin primes 1,037 and 1,039. Past a billion, there's 1,007 and 1,009. In fact, we have found a twin prime that's as large as 2,996,863,034,895 times 2 to the power of 1,290,000 plus or minus 1. That is a pair of numbers each 388,342 digits long. If you wanted to print those in a book.
So this is also very exponential selections.
I'm about to test a machine I'm working on that has 4 really cool pumps controlled by a tiny computer to send 4 different liquids into the pool of water through an injector that I designed, all controlled by my phone. And I don't know if it's going to work, but I'm kind of getting ahead of myself. Let's start at the beginning. I like aquariums, specifically freshwater planet aquariums like this one. To me, these are a ton of fun to set up and maintain over a long time. I enjoy all different parts of the hobby. But some people set up a tank and they just let it be what it's going to be. Let it grow into how it's going to naturally grow. And then other people really enjoy the gardening and the chemistry.
UVC 230 or whatever